Okay, so this is question number 2 from the Stoichiometry study guide. Nitric acid dissolves copper 2 sulfide as follows. You have your balanced chemical reaction there. The first question, calculate the number of grams of each product below that is formed if 37 grams of nitric acid is used in the reaction. So we have calculate the number of grams of copper nitrate and then calculate the number of grams of sulfur. So we will start with copper nitrate first. So remember when filling these in, so in the question they give us 37.1 grams of nitric acid, which is HNO3, which we see right here. And they want us to convert to how many grams of copper 2 nitrate that we have. And so remember, because we are converting from one substance to another substance, we have to use our BCA table. And so we'll use our balanced chemical reaction up here to create our BCA table. So I'll just recopy it here. Now this one's a little crazy just because it has so much stuff in it, but remember, all we really need to focus on is the numbers that they give us and the specific things that we're looking at. So really, all we're looking at is HNO3 and copper 2 nitrate. So HNO3 here, copper 2 nitrate here. So we can really ignore everything else. That'll save us some time and make it a little simpler. So remember, you have 0 of your reactant before the reaction occurs. So again, like we talked in class when you're making cookies, you don't have any cookies before you make them. Same thing here with our reactants. We don't have any reactants before we make them. And then remember your change, our change. So change on the left side of the arrow for the reactants is minus x, but then because that's an 8, it's minus 8x. And then here we gain our product, so we're gonna add. So we would add our product, so that's plus x, but because that's a 3, it's plus 3x. And then remembering that our reactants, one of them is gonna go to 0. It's gonna run out. It limits how much we can make, but because we're not concerned about CUS, we know that HNO3 is the one that's gonna go to 0. And then the last thing that we do is we take the number that they gave us in the problem, 37.1 grams, and we will convert that to moles. And so we put grams on the bottom to cancel out grams. We put 1 mole on the top. Grams of HNO3, so you can use your periodic table to calculate the number of grams of HNO3. And I get 63. So 37.1 divided by 63 gives us 0.589 moles. And so now we can take that number, 0.589 moles, and we can fill it in there. From there, we can solve for x. So 0.589 minus 8x equals 0. 0.589 equals 8x. And we know that x is going to equal 0.0736. And so then we can plug in 0.0736 here. And we can get that the number of moles here is 0.221. So we found copper nitrate, but remember this is in moles. That's what we always put in the BCA table is moles. And so here we have to then take the 0.221 moles of copper 2 nitrate, and we have to convert to grams. And so in 1 mole, we can calculate the mass. You can get the grams from the periodic table. And I will get 187.55. And so we get 41.45 grams of CuNO3 and that would be our answer to A. Now, when we're looking at B, so B is asking us to solve for sulfur. And so what I'll do, and so we don't have to rewrite this table again, what we can do is I can just get rid of this X here that we looked at, or we marked it off when we first started. So if I wanted to solve B, and we can do this because they didn't give us, we're using the same number. So we're using the same number. So in B, they're asking us to go from 37.1 grams of HNO3, and instead of going to convert to copper nitrate, they're going to ask us to convert to grams of sulfur. So we can just use our table here and not have to rewrite it. So because sulfur is a product, I know I have 0. I'm adding the product and it's 3x. And we know we just solved for x was 0.0736. And then I can get the same thing here, 0.221. Which it should make sense that we're getting the same number of moles because we see that the coefficient here is 3, the coefficient here is 3, and we started with 0 of both. So it should make sense to us why we're getting the same number of moles. And so then I can come down here, and all I have to do is convert 0.221 moles of sulfur, which is what we got here. And in 1 mole of sulfur, we can find the grams of sulfur. Again, you can get that from the periodic table. And when you look on the periodic table, you know the mass is 32.06. And so we're ending with 7.09 grams of sulfur. And so there, we can solve 4 grams of sulfur you see right there. All right, so now we will solve number 3 from the Stoichiometry study guide. Same worksheet you're just at, and now we'll move down to number 3. So aluminum metal reacts with iodine to produce aluminum iodide. How many grams of iodine are required to react with 123.2 grams of aluminum metal? So here, what we're gonna look at, what I always start with looking at these, so number 3, what I always start looking at is what am I starting with? So I'm starting with 123.20 grams of aluminum metal. And what am I converting to? And they're saying how many grams of iodine. So iodine, remember, is a diatomic, so it's I2. And they're asking us for grams. So again, because we're going from one substance to a completely different substance, that should be your hint that you need a BCA table. And so when we make a BCA table, you need a balanced chemical reaction, which this question does not give you. So what I'll do is I'll start with writing the balanced chemical reaction. So aluminum is reacting with iodine. Remember, iodine's diatomic to produce aluminum iodide. And so aluminum iodide, it would be Al(I3). Remember, aluminum has a 3+ charge, iodine has a 1- charge. And so to cancel those out, you need 3 iodines. We'll make our BCA table. We always have 0 of our product to begin with. We can fill in the change. Well, first we need to go back and balance this. And so to balance this, I have 3 iodine and 2. So I need to put a 2 here and a 3 here to get 6 on each side. That gives me 2 aluminum, and so we'll put a 2 here and have that balanced. Again, if you need to take a second to balance on your own, you can pause the video and practice balancing and then press play once you have it balanced. Now, here we do the change, so minus 2x, because this is a reactant, and then minus 3x, and then plus 2x over here. Again, the 2 because of the coefficient, 3 because of the coefficient, and 2 because of the coefficient, and we're plussing on the right because we're adding our product. And then the last thing we need to do, here we need to plug in aluminum, but remember you can only put moles in the table. So 123.2 grams of aluminum, we can convert that to moles. We know that the molar mass of aluminum, 26.98 grams in 1 mole. And so then we can solve for the moles. And we should get 4.57 moles of aluminum. And so now we can plug that number in here. And so the question wants to know how many grams of iodine do we need? And so here we're looking at how much of another reactant we need. So we really don't need to look at this part. And so we talked in class, if you remember, one of these is gonna run out, and so we'll put aluminum running out, but we talked in class when we are converting from a reactant to another reactant, we just assume they're both gonna go to 0 so that we can then fill this in and solve for x. And so the number we're really solving for is what number goes right there. So because I have this column complete, I can solve for x. 4.57 minus 2x equals 0. And so we get that x equals 2.285. And we can plug it back in here, 2.285 for x. And so we have to figure out there's a certain number, what number minus 3 times 2.285 equals 0. And so all we really have to do is do 3 times 2.285. And so really, the number that we need to go there would be 6.855 moles. And that would be moles of I2. And when we look at the question, it wants grams. So all we have to do is convert moles, 1 mole of I2 to grams of I2. And we can get that number from the periodic table. And so 126.9 times 2 would give us the molar mass of 253.8. And we're getting a really big number, 1774.07 grams of I2. And so that's the answer to 3. All right, now, so let's look at the next question, number 4 on that worksheet. So we'll go with number 4 on the Stoichiometry study guide worksheet, dealing with iron 3 oxide, reacting with carbon monoxide to produce iron metal and carbon dioxide. How many grams of metallic iron are produced from the reaction of 273 grams of iron 3 oxide with sufficient carbon monoxide? So there's a lot of words there, but don't let all the words confuse you. Again, all we're gonna do is pick out what number am I starting with, which is 237 grams of iron 3 oxide. And so if you remember, the Roman numeral tells you the charge on iron, so that would be 3 plus. Oxygen we know is O2 minus, and so we know that iron 2 oxide is Fe2O3. And what are they asking us to convert to? They say how many grams of metallic iron, so we're converting to grams of iron. Because I'm converting from one substance to a different substance, we know we need a BCA table, and in order to make our BCA table, we need a balanced chemical reaction. And so we'll read our sentence, iron 3 oxide reacts. So iron 3 oxide reacts with carbon monoxide to form iron and carbon dioxide. So go ahead and take a second. You can pause the video if you want, or if you've already worked it, you can keep going, but take a second to balance it. So we got 2 iron here, we need 2 iron here. And when we look here, this one's gonna be a little tricky because I've got oxygen here and here on the left. So 2 places on the left will make it a little trickier. And so I don't really wanna mess with Fe2O3 if I don't have to, because I've already got iron balanced. And so I look, if I can I need an even number on the left, because I have a 2 here, and any number we put here and multiply by 2, we know we're gonna get an even number. So how can I get an even number here? Well, if I can't put a 2, because 2 plus 3 is 5, but if I put a 3 here, that gives me 3 oxygen here and 3 oxygen here with 6. And so if I put a 3 here, that gives me 6 oxygen. And so we're good with oxygen, then 3 carbon and 3 carbon. And so we can make our BCA table. We know that we have 0 of our product before we start. Now that it's balanced, we can say minus x, minus 3x, because that's a 3, plus 2x, because that's a 2, and then plus 3x. And remember, we're adding x on the right, and we're subtracting on the left. Then we look at the problem, 237 grams of Fe2O3 I can convert that to moles because remember, moles is the only number you should be putting in your BCA table. And so we can do, let's find the molar mass of that using our periodic table. And I'm getting 159.7. And so we can get that the moles is 1.484. And so we know that we're starting with 1.484 moles of Fe2O3. This question is asking us nothing about CO and nothing about CO2, so we don't really need to worry about those. This is the only reactant we have, so we know it has to run out. And when you read the question, if you read the question, it says sufficient carbon monoxide. That just means we have as much as we need. So you could think of this as the limiting reactant and this is the excess reactant, because sufficient just means as much as we need. And now we can solve for X. 1.484 minus X equals 0, and so X equals 1.484. We can then plug that in, 1.484, and we can solve for this. And we should be getting 2.968 moles of Fe. Now again, the question says grams, so all we have to do is take 2.968 moles of Fe and say that in 1 mole, there's 55.85 grams. And we can get 165.76 grams of Fe.